Hi, this class I will give the solution for the question 41, 101, and 103 for the binomial theorems as you request. Okay, so we start now for question 41. Question 41. The question wants you to find the binomial coefficients. Expand the binomial by using Pascal triangle to determine the coefficients, and then the question give to you up to power 5 computation here 2t minus s power 5. So this one we can refer to the Pascal triangle in last lecture. Okay, so we draw the triangle, start from the 0 row and next first, second, and third until fifth row, until fifth row. Okay, then we start from 1 here. Next, this is a 0 row, right? And then first row will be 1, and second row gonna be always 1 on the front, right? And then 1 plus 1 become 2. And this one become, back it up, become 1. And this is the first, second, and third. Okay, still 1 at the first one. And then 1 plus 2 become 3. 2 plus 1 become 3 again, and bring 1 down. Next, 1, 2, 3. Fourth, gonna be 1 again. And then 1 plus 3 become 4. 6 plus 3 become 6. 3 plus 4 become 1. And then 1 here. Next it's gonna be fifth row, so it's a 1. Next gonna be 1 plus 5. 1 plus 4 become 5. And 4 plus 6 become 10. 6 plus 4 become 10. And 4 plus 1 become 5. And bring 1 down. Okay, this is a Pascal triangle. Okay, so we need to do up to fifth row because this power 5. Okay, don't forget that. Let me draw this. For this one, we call 0 row, and this one gonna be first row, and this one gonna be second row. Don't forget, this one we learned already last lecture. You can go back to review. Okay, so second row, you can see this gonna be power 2, index power 2. You're gonna have 3 terms, and power 5, that means must have 6 terms. So this second, third, fourth, and fifth, this one is a fifth. This one is a fifth row, which is have 6 terms. We count 1, 2, 3, 4, 5, 6 terms. Okay, now we're gonna work only the fifth rows because question need, because we have index power 5 here. Okay, so now we go back to refer to the variable xy. Okay, this one gonna be the 0 row. That means we have x plus y power 0, right? Because x plus y, anything power 0 over 1, that is equal to this. And this one gonna be, the first row gonna be x plus y power 1. And second row, sorry, gonna be power 2. And third row gonna be power 3. and so on. This fourth law gonna be x plus y power 4, and this one is gonna be power 5. It's on the fifth row. Now we're gonna work only this one, power 5. So from this one, if we expand with the xy, the variable, right? So gonna be, because x is a power 1 here, x power 5 gonna be x here, right? X power 5. And then you keep writing in the to the order, the become in order. So this one gonna be x power 4, right? And then y power 1 plus, next gonna be x power 3, y power 2 in the order, okay? And then x, this power 3 now, next x gonna be power 2 and y gonna be power 3. Then plus x power 4, 3, 2 become x power 1 and y become power 4. And then plus next one gonna be y power 5. Actually, this one x power 1, this one gonna be x power 0, but power 0 anyway always equal to 1. Same thing when this one you see, then you check y power 5, y power 4, y power 3, y power 2, y power 1. So next one, actually this one gonna be y power 0, right? But power 0 is mean nothing. Mean equal to 1, so doesn't affect anything much when we do simplification. Now, from this one, we're gonna insert the coefficient. This is the coefficient, correct? Coefficient for each term. Now we're gonna insert this one. See the first one here, that means gonna be here, right? And 5 is coefficient of the next term here. And next one, 10, gonna be coefficient of this one. Next one, 10, coefficient of this term. And 5 here gonna coefficient of this one. 1 gonna be coefficient of this one, the last term. Okay, so from this one, because question want us, question 41, question want us to find 2t minus s and the whole thing power 5. Then in this case, I use another color maybe here. So from this one, right, you lay down, I lay down here, let 2t equal to x, okay, because x in the first position and then 2t in the same position. Then negative s equal to y, the same position y and negative s, because the whole thing power 5. Then you replace here, wherever x here you replace with 2t and y you replace with negative s, okay? But the coefficient, the pink color here is still there, okay? So now we have 1 times x is what? 2x. 2t. And then power 5. Y equal to negative s. So you just replace negative s power 0 plus 5 still there, okay? So like 5. X again replace with 2t. So gonna be 2t power 4 times y equal to negative s. Y, then this is the second term, okay? Y is power 1 here. Now third term, this is the first term, second term, third term. So third term is what? Plus 10, right? Plus 10. Maybe this one I use plus 10. So you can see term by term, right? This is a 5. And this one is a 1. Okay. Now this one 10, right? For this 1, 2, 3, first term 1, 2, 3. So right now here 10. X replace X with 2t power 1, 2, 3 power 3. And y replace with negative s power 2. Now 1, 2, 3, 4. 1, 2, 3. Now next plus another coefficient for the next term is a 10. Okay. So then you write down x is what? 2t power 2. And y is a negative s power 3. Plus next one is 5. Okay. So 5 times x is a 2t. Here this term, okay. And then y negative s power 4. Plus the last term here. Last term here, coefficients are 1. Align the top. Okay. The last term align the top here. So 1. And then x is what? X is a 2t power 0. Y is a negative s power 5. Negative s power 5. Light clearly. This one s power 5. Okay. So we have 1, 5, 10, 10, 5, 1. So how many terms? 1, 2, 3, 4, 5, 6 terms on the top. Okay. Now I need more space. I move down here. So now we simplify, right? From here we simplify. So become 1. Next, from here we simplify. First is a 1 times 2t power 5. 2 power 5 is what? 32, right? And t power 5. We do step by step, okay? And then minus s power 0 is always 1, correct? No matter base, if power 0 always 1. So plus this one become 5 times 2, 3, 2t power 4, 2, 3, 8, 8 is 2, 16, correct? So we have 16. We have 16, right? 2, 3, 8, 2, 16, yeah, and then t power 4. Okay, and then minus s plus next term. This one gonna be 2 power 3 is 8. 8 times 10 become 80. And t power 3 times s power 2, because this is in even index, so the sign should be plus, right? So become s power 2. Next, this one, 2, 3 power 2, 2 power 2 become 4. 4 times 10 become 40. And t power 2. Okay, so this one, s negative s power 3 is an odd number, so it should be negative. So negative times plus maybe become minus. Okay, can I check it now? Okay, so then you can see the sign here one more time, plus times negative, because negative s power odd number come out negative. So negative times plus become negative. So this one should be negative sign. Okay, this one we change like the way, so save our time to rewrite it. And this one become minus because this one power odd number power, right? So this one minus time plus become minus 2, 2 power 2 become 4, 4 times 10, 40, and t power 2 equal to 3 power 2. And then this is going to be s power 3. We come back to this one, we can change the sign, right? This one, because this one minus s power 1, so come out with negative. So negative time plus here, so become negative. Can I change now here? So we don't need to rewrite it. So this one, I change this one, right? Because this one power 1, so become negative. Negative time plus this one become negative again. Okay. So we change here now better, so don't waste time. So we have 5. We have 5 here, and this become negative, and this is s. Okay, because minus time plus this power 1, right? This one power 1, so become negative s. Negative time plus become minus, and then 5 times 16 times s, t power 4. Okay, now we come back to this one, this term. So plus, now you see the sign first, because minus s power even, so come out plus sign, right? So plus time plus come out with a plus sign. So this one gonna be 5 times 2 become 10t. 10t because this power 1. And then this one become s because power even, so come out with a plus sign. Now the last one you can see 1, 2t power 0 is always 1, right? 1 times 1 is a 1. Okay, so 1 times 1 is a 1. And then minus s power even odd number, you see that odd number should be come out with the negative sign. So negative times plus become negative. Because, see this, because this one, the whole thing here, right? This one, 2t power 0 is a 1. So you time with the pink one here is a 1. So it's a 1. But then you time s, this one 1, right? Time s. So s become, because this one is a light clearly 1 times 1 here, and then s power 5. And because odd even odd number, so come out with a negative sign. Okay, so this one, the last term should be minus s power 5. S power 5. Minus s power 5. Okay, because this one, the whole thing is a 1. So time this. Okay, now we have 1, 2, 3, 4, 5, 6 terms. Okay, now we simplify to the final answer. So 1 times this gonna be 32 3 power 5. And then this one 16 times 5, what we have? 16 times 5. This is a minus, right? 80, right? We have 80 t power 4s. And this one is already there, so plus 80 also. Yes. 3 power 3 and s power 2. And then what we have next, minus 40 t power 2 s power 3 plus 10t s minus s power 5. Okay, so I think this is the final answer. So this is the final answer, okay? So you can see the variable t power 5, power 4, power 3, 3 power 2, 3 power 1, and then t power 0 is a 1. And s power 5, right? S power 5, eh? Yes, s power should be, this one should be power 4 here. Sorry, here. Okay, this one power 4. So this one power 4 here. And this one power 4. So s power 5, 4, s power 3, power 2, power 1, and s power 0 is a 1. Okay, I think this is the final answer. Okay, so then you can see how to use a Pascal triangle, get from this way. You write the Pascal triangle, the coefficient pattern first, and work up to whatever the index, the power question request, like this one power 5, so you work up to the fifth row and continue. Expand this one first and just let whatever term question give to you equal in this pattern, and then you final get the answer here. Okay, then this is question 41, and then question 43. Can you try by yourself? Use the same idea. Okay, so I let you try question 43 by yourself, and then we go to the next. This one I speak slowly because I want to make sure you understand this, so I do step by step. Okay, so now we go the next one, next page. For question 101. Question 101, they want you prove this equation, right? Prove the equation NC R equal to NC N minus R. Okay, so this question not too hard. Can see use the formula of NCR, correct? The combination formula is what? N factorial over N minus R factorial and time R factorial. Okay, so now we can work from left to right or right to left, or we can work at the same time left and right. So we can do right now. I start from the left side first. NCR, so I have N factorial, correct? Over N minus R factorial. This one exactly the formula. And then time R factorial. Then we work on the right hand side. So we start from N factorial over N. Right now R is what? The whole thing here is a R. Become N minus R. So we have N minus and open bracket. Right now is a R. But R is a N minus R right now. Okay. So now we have the whole thing factorial. Time. This one's the R, like here. This one's the R. So big time N minus R factorial. Okay, so then gonna be, after this we can simplify, right? Simplify on the right hand side. So N factorial over, simplify this term, become N minus N plus R factorial time N minus R factorial. Okay, now simplify this plus N minus N is gone, right? So we left r factorial, and then n minus r factorial. You see from left hand side and the right hand side same, right? N factorial on the top the same, and the bottom is what? N minus r factorial times r factorial. Okay, this is the left hand side. So we can conclusion that left hand side equal to the right hand side. Okay, that's the question 101. Now we go to the next question 103. 103 little hard. Okay, but just try first. We work together slowly for question 103. Question 103. Proof also. Question give us to prove this one. N plus 1 CR equal to N CR plus N CR minus 1. Okay, that's a question 1 out to prove. Don't forget we can write in this pattern, right? Otherwise, like in the question, we can write N plus 1 CR like this. It's the same meaning, eh? And then NCR can write as a NCR like this. Or sometimes we can write like this, NR for the combination. Remember for the last lecture, we can write in different pattern. This is the same, equally, same meaning. And not equal to this. Only this one equal. This one not equal. Okay, only this one equal, I think. If this one we can write it down as what? I write down here because I need more space here. Like a N plus 1 CR. You can write in this pattern also, right? Like in the bracket, become N plus 1 R like this. Okay. Similar lighting of this one. Can be lighting like this one also. Okay, now we start to prove. We can prove left to right, right to left, or we can work at the same time, left and right. But I will do most of work, we're gonna work on the right hand side. Okay, so I work from the right hand side first. I work this way, this side first, okay? So we start from formula, don't forget. Again, I erase here. Don't forget the formula. Again, formula in combination, right? The formula combination I write down. NCR equal to N factorial over N minus R factorial times R factorial. This is a formula, okay? So then we work on here, this exact same formula. So become N factorial over N minus R factorial times R factorial. Then this plus do again N factorial for formula combination, okay? Over right now R is a R minus 1. So we have N minus, have to open the bracket. R is the R minus 1 now from the formula. R minus 1 close, and then the whole thing here gonna be factorial time R factorial, okay? R right now mean R minus 1 factorial, so R minus 1 factorial, okay? Then we gonna do try to find this one. We can simplify this one first, right? Simplify this one. So I will keep this, so then this one gonna be N factorial over n minus r factorial. And I will expand this one. I can observe r. I can expand to be like a r minus 1 from the formula r factorial, right? Remember, like we have n factorial equal to what? n minus 1, n minus 2, n minus 3, and so on. Okay, so you replace r, replace n with r, that's all. So apply here r factorial, same with n factorial. So this is going to be r times r minus 1 factorial. I will stop right here because r minus 1 factorial same as this one. So I will stop right here. And then plus. This one simplify the bottom first. Okay, so we have n factorial on the top. And this one simplify become n minus r plus 1, right? And the whole thing factorial. And then times r minus 1 factorial. And then next simplify this one. Then you can find, next you find LCM, right? Find LCM of this one. LCM. How to get LCM? You see, n minus r factorial is a single, right? And this one always single. So LCM, this one common point, common value. So remember we do find LCM by get the bottom here, right? The denominator down here. So we do like this, correct? Find the LCM. If LCM, I can do like this. N minus r factorial times r and r minus 1 factorial. And this term is n minus r plus 1 factorial times r minus 1 factorial. Then you divide it, do the short division, remember? Oh, maybe I use this one. Do the short division. Okay. So now you see this okay. Then we can do by r minus 1 factorial, same way. R minus 1 factorial LCM. So this divide this r minus 1 fact, eliminate, cancel it out. So we left n minus r factorial times r. And this one eliminate also, cut. So we left n minus r plus 1 factorial. So this one, not they are different. So I think that's all, right? So you can have this a factorial. So LCM gonna be this times this times this. Okay, this is LCM. So our LCM is r minus 1 factorial times n minus r factorial times r, and also times this one n minus r plus 1 factorial. This is our LCM. Okay, then you can time LCM, right? Make the denominator here, time LCM to every term, to this term and this term. So we do by n factorial r. So that means we, for the first term here, we time this one, correct? So do this way, n factorial over n minus r factorial. do this one, make it clearly, and time r minus 1 factorial. Okay, then you time else. We have this already and this one, so you time this term, time this one. So we time this top and the bottom, gonna be n minus r plus 1, n minus plus 1. Time this one, okay, n minus r plus 1 factorial, top and the bottom. And then plus also this term, right? This term we have n minus r plus 1 and also have r minus 1 fact. So that means we have to time this one, right, to make it same denominators. So become n factorial. Maybe use different color here. So become n factorial over n minus r plus 1 factorial, okay, time r minus 1 factorial, and then time this one, n minus r factorial time r. This term is n minus r plus 1 over r, right? So time like this, time this one top and the bottom. Maybe I like more space here. Okay, this one is mean this one, okay, same. Now I time this one, top and the bottom. So we won't change the value. N minus r factorial time r over n minus r factorial time r. Okay, so from this we have denominator or the LCM, the bottom are the same, right? So the whole thing gonna be, I like the whole thing now, like this. So the top n factorial time this term on the top, so become n factorial time n minus r plus 1 factorial. Okay, and then plus the top here time this one, become n factorial time n minus r factorial time r, and the bottom is the LCM, so write down become n minus r factorial time, because they are same, when the LCM, just say like LCM here, time r minus 1 factorial time n minus r plus 1 factorial. This is the LCM, this is the LCM same, because you see the bottom same, right? And these are all same. So now after this we can simplify now. We can simplify by which way better? Simplify this one, the top gonna be this one, right? This count this one as a big N like this one. This N right now become N minus R plus 1. So the next term gonna be this N minus 1. Okay. Why 1? Because they eliminate 1 here. So see, I keep n factorial. Because we have n factorial, we can take the common factor. So this one is a n, right? The whole thing's a n. Don't forget, the whole thing's a n. Use this formula. So become n minus r plus 1. Okay, and next gonna be this one's a n, become n minus r plus 1 and then minus 1 factorial. I expand this one, okay, and then plus n factorial. This one change nothing, I want to keep it, become n minus r factorial times r. Then over to draw one line here. Okay, write this one down, LCM become n minus r factorial times r minus 1 factorial r minus n minus r plus 1 factorial. Okay, so from the top right now, take a look. We have the common factor n factorial, n factorial. I can simplify first, make it easier. Yeah. So this same cannot do anything, but this one you see this one plus 1 minus 1 is gone, correct? So we left n minus r factorial. I rewrite down here n and then n minus r plus 1, and this one gonna left n minus r factorial because plus 1 minus 1 is gone. So you left n minus r factorial and then plus this one we keep it, change nothing, become n factorial and then n minus r factorial times r. And the bottoms is the same with this one again. Okay. So this one gonna be n minus r factorial. Just rewrite it, the denominator, okay? So factorial and this term n minus r plus 1 factorial. Okay, after this you can observe we have n I should say pink here. We have n factorial is a common factor. Okay, and then n minus r factorial, same common factor. So we take it out, take common factor. Okay, from this one, maybe I need some more space here. I lay down here, okay. From this line, we go next one. I get common factor n factorial and n minus r factorial common factor. Okay, so now we left this one, correct? We left this one. We left n minus r plus 1. N minus r plus 1. This one. N minus r plus 1, this term, okay? And then plus this one, take out already common factor. So we left r. Okay, we left r. And then close the bracket. Okay. Then the bottom still the same. So I like this one. Divide. And the bottom still the same. So I lie down. Nothing change, okay, for LCM. So we have n minus r factorial times r time this one. Okay, I reline the bottom here, the same thing, nothing changed. R minus 1 factorial time n minus r plus 1 factorial. Okay. So from this one, because it's a time or top as a time, right? Multiplication term by term. And then maybe this one we can see n minus r factorial, same with the n minus r factorial. So we can cut, correct? We can cut n minus r factorial, n minus r factorial. So we left this and this we can simplify, right? Okay, so we simplify the next one. We left n factorial here. And then in the bracket here, we have what? N minus r plus 1 plus r over see the bottom we left r, right? And this one r minus 1 factorial. And this one n minus r plus 1 factorial. So this minus r plus r gone. So left from here we left n factorial time minus r plus r. So we left n plus 1. Okay, so minus r plus r gone. So we have this one. The bottom we leave it still the same, nothing changed. Plus 1 factorial. Now this we simplify this one already. Now we come back to left hand side. This is a right hand side. Like now we work this a right hand side, okay? It's a right hand side. Now we come back to this one left hand side. We work on the left hand side. See, they are equal whether or not. So we work on this one left hand side. The formula again, n right now become n plus 1, r still r there. So use formula become n plus 1 factorial over n plus 1 minus r. So n plus 1 minus r factorial. And then time r factorial. Okay, so you observe this side because we have r minus 1. So I can expand r factorial and the top one. But we have n minus r plus 1 factorial same, right? N plus 1 minus r factorial. So we have simplify this one, use formula this one again, n factorial. Okay, so n this line now become n plus 1. Okay, so we use the formula, gonna be n plus 1 is a n, right? And then next gonna be n plus 1. This one next n minus 1. So this become n plus 1 minus 1 factorial. We stop right there. Over this one's the same, right? So I realize same like this one become I realize just say n minus r plus 1. Same thing, right? And the whole thing factorial. But I want to expand, use this formula again. So right now n is a r, so you become r and next gonna be r minus 1 factorial. Now simplify the top, become n plus 1 time plus 1 minus 1 is gone, so we left n factorial over n minus r plus 1 factorial time r minus 1 factorial. Now you check this is the left hand side and this is the right hand side. Take a look, same or not. N factorial time n plus 1 time n plus 1. The bottom one denominator n minus r plus 1 n minus r plus 1 factorial. Okay, r time r minus 1 factorial, r time r minus 1 factorial. So they are same. Okay, so we can conclusion left hand side equal to right hand side. Okay, this question a little bit hard for your class, but just try for just training our brain. Okay, just see how to use the formula. That's all. Instead gonna be only this pattern NCR, but then R right now become, for example, like this, R become R minus 1, and like this one N, for this one become N plus 1. Just use this formula, the main thing, the main idea. Okay, use this one only, these two formula. Use these two formula. That's all. Okay, so this is a question 103. You take a look and try little by little. But I know this one too hard, but don't be worried about much. But do this question. Just do step by step. See again one more time. If you have questions, just ask me. Okay. I think this question should be good for class AB. Yeah. Okay. Then I think that's all for the question. Your guide request for the solution. Take a look one more time, review and see time by time. If you have any question, right, just ask me in GC again, or the line group, or individual line. Okay, thank you. I think that's all. Bye bye.